Now, this might look like a leftover from a backyard party, but in the modern chemistry lab, it can be a vital piece of safety equipment. For years, the thermite reaction was the undisputed king of classroom redox demonstrations, but 2014's explosive regulations in the UK meant that many of the old ignition mixtures, the ones incorporating barium nitrate 5 and magnesium, could then fall into the place where an explosive certificate was required from the police in order to run the demonstration. This has resulted in some older experiments being removed from the EIC archives. Thankfully, CLEEPs have been extremely busy at work over the last decade or so, and in the intervening years, they've created a whole selection of demonstrations that meet everybody's needs. Whether you need something small, which won't set off a smoke detector, or that you can work in the larger room with heat detectors, making a little bit of a mess, there is a safe and effective technique that you can use. So today we're going to start with a larger variation that's initiated by a fuse made from this sparkler. I'm wearing a lab coat because this demo can be messy and raise a lot of dust. The core chemistry, though, has not changed. We're still looking at a spectacular redox reaction between aluminium powder displacing iron from its oxide. The thermite mixture is 3:1 by mass, so I've got 32 grams of iron 3 oxide here and 11 grams of aluminium powder. Coarser powders often fail to ignite, so make sure that you're using fine or medium graded aluminium. To keep this safe, we're going to mix our powders freshly every time we do the demonstration by pouring them between two pieces of paper. Never stir, as we want to avoid any unnecessary friction. Now we've got two pots here, the belt and braces approach. This ensures that if one cracks under the thermal shock, the other one underneath holds firm. They're about 5 centimeters wide with these little holes at the base. I found them easily online by searching for 5 centimeter terracotta pots. The trick for a good pot scale thermite is in the containment. We're going to use a small piece of paper just at the base there to hold in the mixture into the top flower pot. Our fuse is going to be a trimmed F1 category sparkler. Do check the back on your sparklers. They should be marked for indoor use and they should say category F1. Remove the handle to leave a 9 centimeter length piece of sparkler that will go into your reaction mixture. And I'm going to use some tin snips for this. We placed our flower pots 14 centimeters above this bed of sand. The sand itself is 4 centimeters in thickness so that it can catch and hold on to any of the white hot metal that's going to fall through. I've also, you'll notice, have placed heat-resistant mats all around the equipment to catch stray sparks. The sparkler fuse should sit around 3 centimeters into the mix. Safety is paramount. The audience needs to be 4 meters back, wearing eye protection and looking through a shade 9 passive welding glass. We also use safety screens to protect the audience and the demonstrator, but I do have smoke detectors in this room, so I'm going to head outside. It's a still day, and so I'll be able to do the demonstration out there. Light the sparkler fuse with a Bunsen and retreat to safety. Once the aluminium melts, the collisions become frequent enough for the reaction to really take off. Even after the fireworks are over, the metal stays hot for a long time. Treat it with respect. Once it is cool, we can prove that we've created some iron because it will stick to a magnet. This remains one of the most impressive reactions a school chemist will ever see. Technician notes and the full risk assessment, as always, are available on the EIC website. CLEEPs members must ensure that they look out for the special risk assessment available from them. Read that carefully. If your lab has sensitive smoke detectors, this may be too enthusiastic a scale for you. It should not be attempted outdoors if there is any wind. The mixture has been known to blow in the face of a demonstrator. So if you can't work at this scale, don't worry. in our next video, I'm going to show you Kleeps's microscale version that lets you keep the smoke contained under a large beaker. Until then, give this one a try if you can. I'll see you next time.